Hello, scholars, and welcome to lesson 1.5, midpoint and distance formulas. So in this lesson, we're just using formulas. That's why we reviewed how to evaluate expressions, because all we have to do is substitute our values into our formula and find an answer. So our first formula is midpoint formula, which is basically we're trying to find the middle of a segment. And because we're trying to find the middle of the segment, we take the average of the x-coordinates, the average of the y-coordinates, and put them together. So example number 1 says, find the midpoint of the segment with the following endpoints: 1, -8, and 7, -2. So our first step is going to be to label. We're going to label x1, y1, x2, y2. And you're always going to label like that. So you're always going to label it x1, y1, x2, y2, because it's our first order pair and then our second order pair. And after we label our points, we're going to write the formula, which is the average of the x-coordinates, so x1 plus x2 divided by 2, and the average of the y-coordinates, so y1 plus y2 divided by 2. Then we're going to substitute. So our x-coordinates are 1 and 7. So that's why we label it. So we know our x1 is 1 and our x2 is 7. And then we're going to put that over 2. And our y-coordinates are -8 and +2. And that's going to be all divided by 2. Now we're going to simplify. So 1 plus 7 is 8. And -8 plus 2 is -6. We keep the denominator 2 the same. And lastly, we're going to divide. So 8 divided by 2 is 4. And -6 divided by 2 is -3. And that is our final answer for our midpoint. All right, so example number 2, we're actually finding the distance now. So not the midpoint, not the middle, but the distance of the segment, or the length of it. And so basically this is derived from Pythagorean theorem. So if we have a segment in the coordinate plane, we can kind of make a right triangle from it and use Pythagorean theorem to find essentially the hypotenuse. And so really all you need to know is the formula right here is taken from Pythagorean theorem. So example number 2 says, find the distance between the 2 points, and we're going to round to the nearest tenth if necessary. So we're going to start off with labeling again. So x1, y1, x2, y2. And then our formula this time, again, is right above in the notes there. It's that long square root symbol, x2 minus x1 squared plus y2 minus y1 squared. All of that is underneath the square root symbol. Now I'm going to plug in my numbers. So x2 is -1. So I'm going to write -1 in place of x2. x1 is -4. So minus -4. Notice I have double parentheses because I'm subtracting a negative. And then plus y2 is -9. And y1 is -5, so -9 minus -5. And that's going to be squared as well. And now we're going to simplify inside those parentheses. So -1 minus -4. I'm going to put it way up here. -1 minus -4. Whenever I subtract negative numbers, I keep, change. So keep -1, change minus to a plus, and change -4 to +4. And now -1 plus 4 gives me +3. So this is going to be 3 squared. So let's do another one. Let's put it over here. So -9 minus -5. We're going to keep, change. So keep -9, change minus to a plus, change -5 to +5. And -9 plus 5 gives me -4. So this is going to be -4 squared. Okay. So now I am almost there. I'm going to go ahead and do 3 squared, which is not 6, but 9. And negative 4 squared is not 8 or negative 8. Negative 4 squared is positive 16. Again, 3 squared is 3 times 3, which is 9. And negative 4 squared is negative 4 times negative 4, which is positive 16. Now, I'm going to add 9 plus 16. That gives me 25. And now I might need a calculator in the future, but for this example, the square root of 25 is just 5. If it's another number, like let's say it's 40, right? I'm going to use the calculator, plug in square root 40, and hit enter, and then I'm going to get a long decimal, and that's why I need to round it to the nearest tenth. All right, scholars, so go ahead and try the practice, and let me know if you have any questions. See you next time.